As far as I remember, I always liked solving tough problems. That's what really drives me in science. I'm interested in understanding how our brain works as a single unit, as a whole.
As a scientist, you have to continuously keep your eyes on the development of new technologies and also look for different ways to solve the problem.
My name is Raju Thoma. I'm currently a postdoctoral fellow at Stanford University.
My name is Hongwei Zhang, Associate Professor of Neurology at Keck School of Medicine, USC.
Although we have made a lot of progress in the last century in identifying specific neural pathways that correlate with specific behavior, we have lagged much behind in understanding the underlying neuronal architecture. That's the biggest challenge for this century, to try to understand how our brain works.
Another really major direction for us as neuroscientists is we're trying to understand the etiologies of the neurological or neuropsychiatric disease, for example, Huntington's disease, Parkinson's disease. Our long-term goal really is try to understand what's happening, and we hope our research can really contribute.
We don't understand how these brain diseases are manifested in the patients. I'm interested in developing these enabling technologies that will allow us to image brains at very high wiring level resolution while still maintaining the whole brain broad perspective. We can use these abilities to look at normal brain versus the diseased brain, and then we can try to identify what are the structural or molecular correlates that are causing these diseases.
So at the beginning stage of our Mouse Connectome project, our vision was to construct kind of like a Google map for the mouse brain. So people can search, can view the data, and also analyzing the data, which can be shared by people across the whole world. The technology development is much more rapid than what we expect. So right now, we can collect large-scale, high-resolution image data. The problem we're facing right now is how can we convert this huge amount of data into usable knowledge.
We need to keep up with the changes happening in other disciplines such as computer science or in mathematics or in image processing, so that we can design our experiments and instrumentations to take full advantage of those changes.
As a scientist, we discover new possibilities every day by analyzing our data.
So I'm really excited about the discovery of new possibilities and learning about how our brain works.